General Organic Chemistry, GOC. I'm going to give this video introduction. What's the main parts involving here, as well as importance of GOC also. Try to see up to the end of the video. We'll get some important points. Generally, all the chemical reactions which we are going to study 11th standard, 12th standard, and acidic character, basic characters of different organic compounds, we can see in different exams. They can ask questions increasing order of acidic character, increasing order of basic characters, or intermediate stabilities, like different terms is there in our organic chemistry up to advanced level, even NEET also. So all these things related to general organic chemistry only. If you know basics, then you can study very well those things and we can remember easily. Okay, means with logic. You can solve any question by understanding GOC only. Otherwise, you have to have too many things number of times. We have too many reactions in the 11th and 12th standard for the preparation methods of organic compounds as well as chemical properties. But you understand here properly a reaction mechanism and which is the formation of here intermediates and type of reactions and everything. If you understood basically, then you can apply these reactions in the particular chapter. We can understand easily and we don't want to add most of the things. So anyway, I'm giving here one general equation. You can see AB plus XY gives rise a reaction intermediate or transition state. From that I am getting again AX dy. So what happened here? Bonds breaking occurs as well as bond formation occurs here. So simply chemical reaction is very simple, bond breaking and bond formation. But these are the reactant bonds, which is like left side they given and right side is products. If bond breaking of reactions is if easy, okay, and bond breaking of products is difficult, means that reaction is forward direction is favorable. Or if bonds of reactants is very weak or bond energy of reactants is weak and they are forming strong bonds in the case of products, means that is forward direction is favorable or feasible. So always why they are breaking bonds and why they are forming new bonds means they are trying to get better things. Means very strong bond, less stable bond to more stable bond. They are trying to form that is. And even by changing reaction conditions also, we can get it here, everything. But here reaction conditions will be there. Means that you can say that is temperature, pressure, like that. Maybe we are using solvent also here. Dissolve these reactants. This is the general reaction structure. If you observe step by step here, reactants we are breaking, then we are dissolving or these compounds we are dissolving the solvent, that may be solvent polar or non-polar, and we are getting reaction intermediates, then fall or transition state, then followed by products. See, a reaction intermediates going to be plays very crucial role, very important role in the form of products also. Some type of reactions more important. That some of the products depends upon stability of the reactants only, intermediates only. Stability of the intermediates only decided what product we are going to be get here. Some reaction that doesn't depends upon stability of the intermediate, directly they can form products. That depends upon types of reactions. So reaction intermediate or transition state, before getting product, this is some you can say halt. Suppose you are traveling some long distance from somewhere to, okay, that's approximately can assume 250 kilometers. So somewhere you are taking halt, maybe that snacks breaks or tea break, whatever, like that. Okay. Here we are going to take one point. We are going to stop. Then we are again moving. Like that way only. Here also one of the intermediate steps is the intermediate reactant, intermediate species. That intermediate species differ from reactants as well as products. Sometimes that intermediate can decide product also, which product you are going to be get. Got it? So like types of intermediates and their stability, we need to explain in the GOC. So what type of intermediates is there and which factors affecting that intermediates stability and formation, everything we are going to discuss under GOC only. Got it? Next step. So maybe you have different type of intermediates. You can find out carbocations, carbanions, free radicals, which is single electron system is free radicals. Maybe you have different things, carbenes. Okay. Next, nitrines, phosphorus, ylides, etc. All these are intermediates. Benzene is there, sigma complex. So if you know exactly intermediate formation and their stability and factors affecting, that's we are going to discuss. Even we are going to use some factors which is explaining stability of intermediates. That's even another point is the electronic effects also we have that one. Electronic effects is also more important in the case of stability, ST character, basic character, too many things. These are going to be affecting. That's maybe inductive effect, resonance effect, hyperconjugation, electromeric effect, electromeric effect, like this. Different things is there we are going to be studying with respect to those also. And here ultimate thing is bond breaking and bond making. That's we are thinking. Here bond breaking again, two types. Okay. That's homolytic cleavage and heterolytic cleavage. Types of bond cleavage. You can check it here. Homolytic cleavage and heterolytic cleavage. Homolytic cleavage means these are the electrons. You can find out very clearly here. Two electrons is covalent bond. And we have to know nature of the bond between reactants, how they are breaking. That may be ionic bond, covalent bond, and most of the reactions we are going to discuss here covalent bonds only. Here equally breaking electrons. That's we call homolytic cleavage or symmetrical breakage. Symmetrical breaking, breaking or cleavage. Okay, symmetrical means exactly half we are breaking. That's we call homolytic. Then we are getting single electron system. That's we call these are free radicals. These are highly reactive species because here we have only 7 electron system. This unpaired electron is there one unpaired electron. You may can consider these are paramagnetic in nature also, but highly reactive species. It occurs in presence of breaking of homolytic cleavage occurs in presence of help. Help means H means heat. I provide very clearly. H means heat, E means electricity, L means light, P means peroxide. And non-polar medium also required. Non-polar means mu equal to 0, dipole moment is 0, which is those solvents we called non-polar. Got it? So I'm giving here, you can see with respect to art also I shown that one. Exactly equally are breaking. You may can take different bonds here. Hydrogen. We can use sunlight, that maybe UV light you can take it. It can break, each bond contain 2 electrons. For breaking, we can get here C radical, H radical. These are highly reactive things, they can react easily. We can get here different things. CH3Br. That depends upon situation. We can heat very high temperature or light. You can break it here. Each bond contains 2 electrons. That is also sharing of electrons. You can break it. So this we call homolytic cleavage. This occurs generally non-polar medium also solvent already know that one. These are we call free radicals. Free radicals. These are highly reactive. Highly reactive and unstable also. Highly reactive means only unstable. That's you can find out very simply. And next one, heterolytic cleavage. Heterolytic cleavage means here both have electron difference is more than 2. delta En is more than 2, greater than 2. Here delta En is above cases is less than 2. So you can break this bond two chances. Maybe carbon by breaking unsymmetrical. This is okay. This is unsymmetrical breakage. Unsymmetrical cleavage or breakage, whatever sir you can take it. Cleavage. So when you are breaking unsymmetrically, one carbon may, if you suppose Y is more electronegative than carbon, then Y will get negative charge, carbon will get positive charge. Or carbon is more electronegative than Y, then you may can get it. This is negative charge and positive charge. For example here, but here you may require polar solvent also. There may be solvent required. Polar. Polar means mu not equal to 0. You may can take H2O, ammonia, etc. These are the solvents. Now you can find out here CH3, CH3, H, Br you can take it. You can break it this bond. Bromine is more electronegative. You can take it Cl also doesn't matter. Then we can get it here CH, CH3, positive charge plus Br minus like this. So positive negative charge we are getting. These are heterolytic cleavage. Heterolytic we are getting two different. Clear? So you can find out again other examples also you may can find out. Carbon, hydrogen. This is aldehyde. Now I am taking here some OH minus. It can take this H plus ion. Then we are getting here CH2 minus CH1. Here we are getting negative charge plus H2 anyway. So negative charge. This is also electrolytic cleavage. So like maybe that depends upon situations where we are getting positive and negative. These are types of bond breaking. So what we discussed here, introduction of GOC, then bond cleavage we discussed, that is heterolytic cleavage and homolytic cleavage. Due to homolytic cleavage, we are getting free radicals. These are highly reactive and unpaired. Maybe we can say paramagnetic character also. Heterolytic cleavage means unsymmetrical breaking. Then you can get it here positive negative characters. How they are forming we given clearly. Okay. Next we onwards will discuss what is the attacking reagent and substrate and reaction intermediates like that. Thank you very much. Try to subscribe and share it.